So thanks to Hazen for letting me kick off phase 2 of Canada One Water, which I'm co-leading with him, carrying on from his previous 3 years, which he presented before, doing an immense amount of work. And now we'll move on in EGP with this project. And I won't read the abstract, so you don't. Now that we have the models built, is how can we apply them, what can we do with them, and where will we go? And again, same team as before. We've added University of Alberta with Dr. Brian Smearden to move on to the application phase of the project. And of course, we saw the overarching objectives of Canada One Water, which Hazen has presented earlier today. And we'll get into what phase 2 is. I'll just go through this slide quickly. So, of course, as a continuation of the project, we'll be looking at indicators of groundwater quantity. We'll be using GRACE to look at trends in total water storage. There'll be a smaller scale look at water budget closure, and then application of a specific model to look at indicators. And as was discussed earlier today, we're having ongoing base data enhancement, or CAN, and communication.
Yeah, je passer à la suivante, s'il te plaît.
Okay, so the main science objectives are the first year to do a review of the use of indicators for groundwater to provide total water storage changes for all of Canada using GRACE, to implement public delivery of the GRACE water storage changes so that people can access it both through the Surveyor General Branch website, but then at an easier to use scale through the CAN base. And then continued development of a land surface model ELCO for baseload water capacity. So the first step for groundwater, it makes it really hard to manage water, to plan ahead, and meet our sustainable development goals. So there'll be a literature review this year to look at what exists within Canada, because there are some indicators for surface water, and what we can develop. The next is GRACE. For those not familiar, it's a gravity recovery and climate experiment. It's a 2-satellite system that passes each point in Earth once per month, and it's measuring gravity. The component of gravity that changes once per month is actually water. And so it gives us on this 100,000 kilometers square scale changes in total water storage. And you can see here, this is what John Crowley has produced at a national scale, 20-year changes across Canada. Some places are getting a lot wetter, some places are getting a lot drier, and some places are staying kind of the same. What we're going to do is look at that at this 70 watershed scale that Hazen showed in his previous slide. You can see there's a bottom on the bottom there, the trend, seasonal trends for one of the watersheds, Porcupine and Fawn. The next phase is water budget closure. So what this basically is this precipitation equal to the outflow from surface water, the evapotranspiration. And this is carrying on from work in 2014 by Sushen Wang. And you can see he's done it for several of the 360 something watersheds in Canada. And there's various levels of closure. And so some of that could be because the data support, so climate data isn't good enough to get closure. But the other part of that we're going to look more into is that the amount of water storage, like what we see with GRACE, is actually changing. In that case, this budget won't close. And the next phase, or the next component of this, is led by Stephen Pride at Quanti and with the University of Alberta. And that's really looking at, can we use the Canada One Water models to look at how much water storage there is at different scales? And can we make indicators based on what we've seen in the last 20 years and make that forecast? So incorporate it with GRACE, use it to give us a bit of at least 1 year projection into water storage changes. And so the first place that this will be done is the Nelson River watershed. This was chosen, of course, because there's high water stress here, high consumptive needs, but also because it's covering a large physiographic region from the side of the Rocky Mountains all the way up to Hudson Bay. And if I can press play, there we go. Base data enhancement will be ongoing, as in any modeling all the time, but working to improve parameterization, so what hydrogeological parameters are we to represent it. Heather Crow will be working to update a national data set for geophysics, and as Hazen alluded to earlier, this will be going on in the background of everything. So in summary, Canada One Water Phase 2 is the 5-year project to enhance groundwater quantity forecasting abilities at national scale, carry on publishing all the data from before and all the time before. We're going to develop indices to inform water quality. We'll be using GRACE data both to validate the model that we've built so far and to quantify water storage changes and what part of the water cycle is changing. Land surface model. Look at the Nelson to generate these indices as a starting point. Enhanced base data, and of course, always continue the dynamic and engaging communication that was demonstrated in Phase 1.